Hello, my name is Orlando Karam. The contact info, there's my email, okaram1@kennesaw.edu, an alternate email, orlando.karam@gmail.com, and that can also work for Google Hangouts. Please try to keep official stuff on the official email because of privacy reasons. Once it goes to Google, who knows what they do with it. So grades or anything, if you're mentioning your student ID, right, then it should be on the official email. All this is on D2L, and the lectures are recorded. There's my cell phone. Feel free to text me. Use judgment before calling me. I can always ignore a text. It's slightly more painful to ignore a phone call. I do work (9 to 5). I'm an adjunct here. Let me update. Don't expect any answers to emails or texts or anything like that at like normal business hours, because I'm in my real job. This is what I do for fun. How weird, but does that make sense? I will try to answer, and if there's anything urgent, you can text me. I work 9 to 5, right? So if you see me at night at 11 p.m. on my computer, it's probably because I'm on my computer, so feel free to reach out. It's okay. I tend to not log on, except my phone may log me in. I tend to not log on during the day because I'm at work. Let me quickly go over syllabus stuff. Again, that's my name, Orlando Karam, and all my info is on D2L. I don't put it here because spammers may get my email. The course description, you can read it. What are we trying to do? We are trying to teach you how to program, right? And Java is what we use. And you will feel, especially in the beginning, that we're teaching you Java, and the first month is all about where the heck does the semicolon go. But truly, the point is not to teach you Java. The point is to teach you how to program. And we need some language to do so. And so we use Java. We could have chosen any of the 17 other languages. We just happened to choose Java. Important thing, this is an accelerated class. This is the XXX. This is the adult version of the class. At the undergraduate level, we have two classes, CS1301 and CS1302. I don't know, or CS1 and CS2. I don't know what they're called. I have reasonably young kids, so I still keep my phone not on vibrate, but I should. At the undergraduate level, right, we have two programming classes. And this class covers both of them, right? The undergraduate level, we have two classes with two labs. So it's 8 credit hours. We do it in 3 here, right? Why? Because you're adults, and we can work you harder. No. Yes. 18-year-olds, they don't know what they want, right? There has to be a lot more hand-holding. We are assuming that you guys are adults. We are assuming that you have had more experience with computers, maybe not directly programming, right? And we're assuming that you can monitor your learning and ask for help, right? If you want to learn, I want to teach, I will hold your hand, whatever is needed, right? But I'm normally assuming that you don't need hand holding and that you will breeze through this. It may not be true, right? It requires a lot of effort, it requires a lot of time. This intro to programming class is kind of drop and give me 20. You need to be doing a lot of exercises, right? Just like with everything else. Like batting in baseball or something like that, you just need to swing a million times. So that's what we'll be doing here. Plan on spending tons of time. But it will be one of the most fun classes you have had, I promise. It will be fun. It will be painful, but it will be fun. The textbook I will be using is Think Java, How to Think Like a Computer Scientist, and it is freely available on the internet, legally. You can also buy it and pay money and get a printed version. May not be a bad thing, but I also provide ample notes and examples and things like that. Course objectives, and these are copied from whatever our standard catalog, demonstrate skills at the end of this course, right? You should be able to demonstrate skills, use of core programming concepts, data types, arithmetic expressions, control structures, logical expressions, selection and repetition, master basic class and object-oriented concepts, solve programming problems, and demonstrate an understanding of file I/O and exception handling techniques. So basically, you will have a decent clue about programming. This is not the class that makes you a programmer. This is the class that takes you from 0 and gives you a clue. Data structures is the class that makes you a programmer. But this class is weird. If you have done any programming before, if you did BASIC when you were a kid, if you have done Python, even if you have used tons of macros in Excel, you'll breeze through the class, it'll be easy, life will be good. If you have not done any programming, this class is gonna be hard as hell. It's gonna be fun. We are warping your brain and teaching you how to think in a different way, which is amazing, should be transformative. At the end of this class, you should be like, wow, now I can think this way. But it should be painful because we're trying to make your brain different. There is no other way, but it's worth it. It's gonna be fun. Grading is standard, 90 to 100, you get an A, 80 to 89.99, you get a B, and so on. We will have online discussions that are worth 5%. Programming assignments are worth 35, and we'll have basically one per week. We'll skip a couple of weeks in the middle and stuff. I think we have like 11 assignments, 10 maybe. And we have like 14 weeks if you count spring break or the other one, Thanksgiving and stuff. The midterm will be worth 25%, and there will be a final that will be worth 35%. Deadlines, I will try. In fact, I think I'll do it forever, but deadlines are Sunday at 11:59 p.m. with a grace period until Wednesday at 6:29 p.m. If I remember, between Sunday and Wednesday, you would lose 10%. I normally don't enforce it, but I want you guys to not think of Wednesday as the deadline, because if you do so, then you may miss the deadline. Why is the deadline Wednesday at 6:29? Not to make you suffer, that's just an added bonus. It's so we can discuss solutions in class on Wednesday. So if you ask, and we will do that. We will not do it before that. Academic misconduct, if you cheat, I'll come down on you as hard as I can, because it sucks, and it devalues the degree of everybody who comes out of KSU. So don't cheat. If you have a question about what is cheating and what is not cheating, ask. Ask beforehand. Even it sucks, but you could ask after, and you may get a 0 on the assignment, but you're not cheating, right? If you cheat, then I will do all that the university will let me. Important thing, I don't do curve grading. You're not competing with anybody. If everybody gets an A, I'll be super happy and give everybody an A. If everybody gets a C, I'll get really depressed, but still give everybody a C. Does that make sense? One important thing, for programming assignments, that's going to be what you're going to be graded all the time, right? And those are kind of the early indicators. Most of the time, you should be able to, they should be straightforward from what we saw in class, should be able to go do them an hour or 2 or 3, and you'll be done. Sometimes, and almost everybody will hit these 1 or 2 weeks where an hour or 2 or 10. And sometimes it happens. One problem with programming is that it's not linear effort. With many other things, if you need to write an English paper, if you put 80% of the effort, you get an 80, right? With programming, 1 minute before your program works, it doesn't work, right? And so 1 minute before you get 100, you have a 0. It's not that bad, but, right? So manage your time, start early, ask for help. I do expect that the programs that you submit will at least compile. I tend to not look at stuff. If it doesn't compile, I don't give you partial grading, I get mad at you, give you a 0, and go grade the next person. So make sure that what you submit compiles. And you will have ample time to, you will see, and we'll talk about this, and we'll do, you submit for code review, right? You can submit early, you can submit incomplete, you can submit with help. I cannot do this, right? And I will, try to give you feedback. You can submit as many times as you need to within the constraints of a week, so probably 7 times or something like that, right? And it is perfectly okay, right? So if you start early, you get stuck early, you can ask for help, you'll get unstuck. Life will be good. If you put the effort, it will work out. But if you start a day before, bad things might happen. You may be lucky and you may get it and it may work, or you may get it and be in trouble because of a semicolon that's in the wrong place and get a bad grade on an assignment. So start early, do it in small pieces. We'll talk more about that stuff. I try to answer emails. I try to be professional. It's not, I don't terribly care. But try to be reasonably professional. I try to answer within 48 hours. That's kind of my SLA. I usually answer earlier, but keep in mind, I work 9 to 5. I will not answer to you within those times normally. Feel free to bug me more if you don't get an answer, right? If you don't get an answer within a day, send me another email, text me something, and I will try. Makeup policy, if stuff happens, we'll work it out. But it should be an extraordinary reason, not normal stuff. religious observance, if there's something specific, you can tell me. Usually you will know well in advance when is Hanukkah or whatever. And you can tell me and we can work through. Normally, other than the test, there is no, because you have up until Sunday, but you can submit on Saturday or on Friday, right? So there's usually not a problem. But if you have a disability, let me know. Go through the right process and I'll work with you any way I can. If you don't let me know, then I have no clue what you have and I'll treat you normally. If that's not the right thing, ask. Squeaky wheel gets the oil. If you don't squeak, you don't get oil. The course schedule is a plan, it's not a contract. It will change. I'll try not to, but it might change. And there will be 2 proctored exams, a midterm and a final. You guys, I expect you to come at the time. I do make arrangements for online people, and some of them will be watching the recording, right? We'll figure out for the online people. Sometimes this ends up being an advantage for face-to-face people, because if you could cheat if needed and do this stuff with the online people or something like that. We'll give for a little bit more flexibility. Hopefully a bunch of the online people actually can come to the date and time of the test and just take it with you all. We'll see, but especially if you're online, keep in mind that there's at least 2 proctored exams. I don't keep attendance. I hope that you find the class useful, but if you have better things to do, go do them. I'm recording the class, it's not the same. A video doesn't answer questions, but it will be there. And so if at some point in time you get stuck in traffic or something happens, then it's okay. You don't even have to tell me or anything like that. Again, you're adults now, which is good and bad. How can you succeed? This class is planned, truly, and by now I've been teaching this class. Maybe this is the 4th or 5th time that I teach it, almost the same way. There's a bunch of people who have never taken a programming class before who have succeeded. It's a lot harder. It's a lot easier if you have done some programming, but it is perfectly doable even if you haven't done any programming. Anything that you have done that's programming like, HTML, Excel spreadsheets, all of that stuff helps. So try to think about all the things that you have done and prepare for reusing all of that knowledge. This is a 3 credit hour class. That the kind of rule of thumb, right, is a graduate class. So we meet for about 3 hours if you meet. If you're online, then you watch videos or whatever for 3 hours. And then you're supposed to put about 3 times as much outside of the classroom. So many weeks, not necessarily every week, but many weeks, you are expected to be putting 9 hours a week besides these 3, right? Some weeks, you may be putting 15 hours a week, right? Because you didn't get it, or you spent 2 hours cycling on a semicolon, right? Some weeks, life will be good, you'll come to class, it will all make sense, your program will compile magically, and you'll be done in 5 hours, right? But be prepared to potentially be putting 12, 15 hours a week. This is one of the kind of the hardest things, right? If you know that you cannot, right? And it's not a matter of how good or how bad you are. It's not a matter, it's just a matter of do you have the time, right? Do you have the time right now realistically, right? If you work full-time, and full-time means 24 hours a day, and you have a family and 2 babies, this may not be the right time to take the class, right? If you cannot realistically put 10, 15 hours a week, then this may not be the right time to take the class. If you are taking 4 classes because you want to get done with the MS earlier, 4 classes at 12, 15 hours a week is a full-time job. If you have another full-time job, that's probably not going to work. It might. I know people who have done it, but it's not the norm, right? So think about your schedule your time. If you can, schedule this stuff earlier, right? Like, you should take a look at the assignment on Monday, right? Or even before, right? Before we have covered this stuff. You should plan on really working on the assignment on Wednesday, so that if you get stuck, you can get unstuck fairly quickly, right? Don't plan on working on the assignment Sunday morning. Even if you have 15 hours on Sunday morning, that's a very risky proposition, right? Because if you get stuck, then you're stuck. So keep that in mind, plan yourself, schedule ahead. It will be easy. You can ask for help, right? You can actually send me your code. That's the idea of a code review. So you send me exactly what you have. You can ask questions. You can get feedback. It should be easy. It's easy if you start early. This is probably the main thing, right? Put the time, start early. This is probably more important than anything else, right? Make sure that you start early. If you try the assignment on Monday, right? You can come and ask questions on Wednesday, right? And so you can get unstuck. If you start early, life will be good. This will be an easy class. Just do that. Make sure that you don't fall behind. We do build upon what we are doing. So if you notice you're missing something, ask for help immediately. You're adults. I'm going to treat you like adults. I'm assuming that you guys can monitor your learning. I'm assuming that you guys can say, oh, I don't know this stuff, right? And then ask questions. I also, although we do a lot of repetition in the class, different people are going to need different levels of repetition. So rather than make everybody do 500 examples, right? I make everybody do 1 or 2. And I expect that you, on your own, will realize, oops, I haven't gotten this thing, so let me do 10 more, right? And it is this repetition, this practice, that will make the class easy, will make you a good programmer. You need to be doing it. We'll see a bunch of things that will help. Ask for help. If you want to learn, I want to teach. But if you don't ask, I'm assuming that everything's good, and then you flunk the test. Embrace the technology. We will be using standard programming tools for this class, right? We have the advantage that this is computer science, right? So we actually build a bunch of programs to help us make our job easier. It will not make your job easier if you try to avoid using the programs or something like that, right? So make sure that you set up your machine, make sure that you can use the programs, make sure that you can send code reviews, right? Pull requests or merge requests or whatever, so that you can get the feedback, right? And then life will be good. I give you unit tests, so you can run a program that runs a bunch of tests on your code and tells you your grade on the assignment, right? Just run that freaking thing, right? I mean, and run the program. Computers are cheap. Run those things over and over, right? Make the compiler do your work. You write 1 line of code and compile, right? And so if something's broken, where's the problem? One line of code, right? If you try to write a full program, if you write a page, it's wrong and you're doomed. Because you don't know where the heck is wrong, nothing's gonna compile, you're gonna have a hard time. So use the compiler, use the IDE, embrace unit tests. They'll make your life so much easier, right? Embrace code reviews, send me this stuff, right? And use the assignments wisely. Many times, people get too much help with the assignments, right? Not purposefully cheating, right? But just, I work with these two other programmers, right? And I can get help. Don't do that. Don't cheat yourself, right? Because then on the test, you will bump it. You won't learn this stuff. So make sure that you are doing the stuff that you are learning, right? And if you happen to be discussing and somebody gave you the solution, maybe do another similar problem so that you get the practice. Does that idea make sense? Cool. We are done. Just so you know, we have due dates. I'm gonna change something around here. But I'll change something around the end. But first assignment is due Sunday, August 13. I'm an idiot. That doesn't make sense. I'll go change stuff.
You have a panic email from me about that.
Oh, good. God, no, that doesn't make sense. Why aren't you guys done with your assignment? You're all late. Now the first assignment, assignment 0, will be due on the 20th, and it's actually just about installing stuff on your computer. You will be compiling, you will be sending a code review, but I give you the code. So it's more so that you install everything and can send code reviews and things like that. And that'll be due on the 20th. And I'll come change this stuff. Yeah, I'll go review this stuff. But the due dates are there. They're false, but they're there. I tried to collect resources. There is a bunch of Java textbooks. We will be using Git as our version control stuff, so there is that stuff. These two things are amazing. I do expect you to, we broke it. Never mind, it just broke for a second. I do expect you to install everything on your computer, right? I mean, do expect you to install Java, Java compiler, an IDE, a bunch of things like that. We can do this. Maybe you guys can actually see. But you don't always have your laptop with you, right? Java REPL is amazing. Java doesn't actually have a REPL. REPL stands for read, eval, print, loop. You type stuff and it immediately tells you the answer. So you could use it as a calculator. If you type the number 3, it evaluates to 3. If you type 3 plus 4 times 5, it will print what? Maybe 23, maybe the other one, 23, right? And that will, oh, okay, so now I know the order, right? If I do 3 plus 4 times 5, then it will print 35, right? And you can come and see, and if I print math.abs minus 1, oh, that's how I get absolute numbers, right? And you can come and practice that stuff and do a million tiny things. wherever you are, right? So that can help you get tons of repetition wherever you are with a browser. I will use this sometimes during the class. Coding Bat is another site for that kind of stuff. They have super simple things with unit tests. Return the absolute difference between n and 21. If n is over 21, return double the absolute difference. Yeah, we can't do this yet, but okay. So something like this, we could return false. Booleans are true or false. And it runs, and it tells me, right, well, that's not true, right? I'm supposed to return, we're in trouble if they are both smiling or if neither of them is smiling. So a smile and B smile. And we'll see all this stuff, right? I'm just trying to give you a quick. Yay! You can do these things literally in a few minutes, right? Which means that you can do, you have 15 minutes somewhere, right? Between classes or something like that. Go do that stuff and go do a few, right? It's gonna make it a lot easier if you do 15 minutes a day than if you do 7 times 15. 100 minutes on a week, on one day or something like that. Does that make sense? So use these things, right? If you have your laptop, then even better, and actually do this stuff. But try to do all the practice you can get in all the ways you can get. Even if you like wasting your time on Reddit, waste your time on things like Learn Java, or Learn Programming. Okay. Questions? Not yet? You all have used D2L, right? Desire to learn? Cool. 100 years ago, this used to be WebCT. D2L bought WebCT, so I still call it WebCT half the time. For the most part, my modules have the materials, which are actually on GitHub, the assignment, and then sometimes a couple of more effective domain questions rather than technical questions, and then one thing for you to ask questions about the material. Sometimes I have videos for people who prefer to learn with videos, and I will be recording the classes, the lectures. So let's talk a little bit about programming. You program in a programming language, which is sort of like a very formalized version of English. And we're in the US, so we use English. Computers actually don't understand that stuff. They understand machine language. So you need some form of translator, right? From that language, and the language that we'll use is what? Java. To machine language, right? We tend to call that a compiler. We actually complicate this stuff with Java because Java uses a virtual machine, and so a compiler is a slightly bad term for what it does. The thing is that you use, the machine language is different, right? My laptop uses an Intel kind of processor, so they have a different machine language. My phone uses, I have no clue what, but let's assume there is an ARM processor that has a different machine language, right? And your phone may have a completely different processor with different machine language. So many languages compile directly to machine language. C and C++ are kind of the obvious examples. For a long time, and then it kind of revived with Java. Java, rather than creating a compiler for each one of those different computers, creates a virtual machine, creates a simulator of a computer, and then you always compile to this virtual machine. So the compiler doesn't generate machine code, generates virtual machine code, JVM instructions, and then what the guys who made Java have to do is create a JVM for each different platform. Does that make some sense? Cool. Your program is text. What do we use to deal with text in a computer? A text editor. What else do we use to deal with text? What's when you need to? Yes, a word processor. Like what? What's the standard word processor? Good. WordPad. Notepad is a text editor. It's a horrible one, but it's a text editor. WordPad is a word processor. What's the other word processor? Microsoft Word, right? Don't ever, like delete it from your machine. Don't ever use Word for programming. Why? Because it helpfully autocorrects your stuff, right? And mangles your code beyond recognition. It will just destroy it, right? It will helpfully convert your quotes so that one goes to the left and one goes to the right as it should be in English, and your program doesn't compile, right? Don't forget about Word, right? Use a text editor that doesn't mangle your text. If push comes to shove and you're on Windows, Notepad would do, but I would strongly recommend not using Notepad ever. Not ever, but if you have any other alternative. If you want Windows specific, Notepad++ sucks a lot less than Notepad. Also, Visual Studio Code, not Visual Studio, VS Code, is a fairly nice, simple text editor that does syntax highlighting and stuff for like quick text editing. We will leave editing text, right? You could use a text editor, then a compiler, right, to compile and run. So let me do this stuff. Let me just get out of here. And I'm going to be an idiot and use Vim. Because VI is the standard Unix text editor. It is horrible, but you get used to any kind of abuse. And so I can normally use it. It's programmable, so it lets you do all sorts of magic. People who really know VI program their text editor so that they just press one button and it does everything. We have, in the Unix tradition, VI and Emacs, and they're both hideous. But they're programmable, so you can make them do whatever you want and make them really cool. But I'm using just a simple. So we could use anything as our text editor, test1. Given that our program is called test1.java, we are going to have to create this. And then we will create a main method. All this looks like weird black magic, right? We'll explain all this black magic. in 2 weeks, it will look a lot less by black magic. At the end of the course, it'll be super easy, right? But we are defining a class. We're calling it test1. It has to be named test1 because our file is called test1.java. We are defining a method called main, and that's where the execution of the program will start. And then I can do the standard. Print hello world. Save, right? This is just a normal program, a normal text file, right? I can use javac to compile it. And then Java to run it. And it ran, and I printed hello world. Woohoo! Isn't that cool? Should be amazingly cool. On the other hand, if we're going to be doing this all the time, right, we end up using a couple of other tools. One of the other things that you can do, one thing that I can do is use better programs that do some of this stuff for me. We'll use Gradle, and I'm going to talk about this in a second. The other thing that we can do is use something a little bit more specialized than a text editor, something that doesn't just let me edit text, but is specific for editing Java text, right? And so it has special keys for compiling and running and all of that stuff, right? It's like a text editor, except that if I press Shift F17, it will compile. Does that make sense? Those things tend to be called IDEs, Integrated Development Environments. They understand our programming language. They can do some of this stuff for you. You shouldn't rely on your IDE, right? You should be able to do normal stuff for a normal text editor, but it helps to have an IDE. They will do syntax highlighting. Your text editor will do that too. They tend to do auto-completion. They kind of understand what methods you can call, and so it will give you lists of the things you can do, which can make your programming easier. Sometimes it makes it hard to memorize stuff because you never memorize it. You just pick from a list. So don't overdo it because it may make your exam not as good as it should be. There are many IDEs available for Java. The educational ones are Dr. Java and JGrasp. We don't do those here. You're adults. We'll use adult versions of tools. There is 3 free professional IDEs: Eclipse, NetBeans, and IntelliJ IDEA. And I lied in there. I'll actually be using IntelliJ. Sorry, my brain is now warped. It's what we use at work. So it's what I use. All 3 of them are actually fairly good, fairly usable. I think Eclipse and NetBeans are completely free and open source. IntelliJ has a community edition that is free. I think the Pro edition is free for students. And then they expect you to eventually give them money. The free edition, the community edition, is more than enough for what we do. I normally, that's what I use. That's what I have on my computer. I don't have the Pro edition. If you already know a different IDE and want to use it, that's perfectly okay. If not, I would strongly recommend you go with the flow, not for any particular reason other than if we all use the same thing, it'll make it easier for help and support. Although most of the stuff will be without an IDE. I'll not be helping you with your IDE, I'll be helping you with the code. But all 3 of them are actually fairly good. We are lucky we have tons of free tools. Now, what we will use, because it makes my life easier, and hopefully yours too, but is Gradle. In the beginning, there was Unix. When we started developing stuff for programming, for programmers, kind of the history of computers starts with Unix. There was prehistory before. One of the standard things is, well, if you have a bunch of different files, right, and you have to compile them and then link them together, could we just have something slightly smarter that will look and say, oh, you've already compiled this one and it hasn't changed, so there's no need to compile it again. I'll only compile the stuff that changes, right? And that is what make was. Eventually, every other programming language under the sun came up with similar ways of doing that stuff, right? Java has a bunch of them, has in heavy use, Ant, Maven, Gradle, and then there's a couple more for other Java stuff. There's like Basil and something else, SVT. We'll use Gradle because that's what I use. They're all good. They all suck. There's two kinds of programming languages, right? Those that people complain about and those that nobody uses. So it's the same thing with build tools. There are those that people complain about and those that nobody uses. So we'll use Gradle there. I like Gradle a lot better than Ant or Maven because those two use the XML, and I despise XML with passion. What Gradle will do is give you a command line interface where you can just type a command and run all the tests and get, these are the tests that are passing, these are the tests that are filing, this is your grade. And also send pull requests or merge requests and those kinds of things. We're going to use the command line a lot. Why? There's two reasons. First of all, we are doing programming. We are doing tech stuff, right? You shouldn't really be touching your mouse that much, right? So it makes perfect sense to Alt-Tab and type more commands. That's what you're doing anyway. The other advantage, and that's mainly for me, but it also helps you, is that trying to help somebody with a GUI is horrible, right? Especially remotely, over email or something like that. Like, or imagine over a phone, right? Click on the greenish thingy on the left. God, no, right? Whereas with commands, I can tell you type this and you just cut and paste it, and it works. So it makes debugging and helping so much easier. So we'll be using Git Bash if you're using Windows, or just plain Bash, or the terminal if you're using a Mac. And then we'll use Git. We'll be using Gradle for that stuff, for just running tasks. And then we'll be using Git for version control. How do you do version control? Imagine that you're doing a big Word document as a team project. What do you do? It's called assignment 1. What do you do? Create a file called assignment1.doc, right? And then you start getting scared that you may lose it. So what do? You save it, and then you send it to your friend, right? And then you keep working, right? And then they email it back to you. What happened? They edited their version, you have your version, right? So what do? You save the version as assignment1_Kevin, right? Or whatever the name is, right? And then you start, have you done that stuff? Isn't it a mess? Yes, right? We sort of kind of do it. Well, computers are really good at keeping track of stuff, right? So we came up with version control systems that basically you say, hey computer, here's a new version. And the computer will say, oh, Kevin entered a new version at this time, right? And they'll create branches, right, from this version, right? And sometimes they can merge because it's just text, right? So many times they can auto-merge. Just say, oh, you worked on chapter 1, Kevin worked on chapter 2, so we can just add your changes to chapter 1, Kevin's changes to chapter 2, and it's all good. And it sometimes even works. So we will use Git as a version control system, and that's what you will be using for sending merge requests. Basically, you get code, you make changes, and then you send me a merge request. Would you merge this? And I can look just at your changes, which makes my life so much easier, but also makes your life easier because I can give you comments, right, and say, change this line or something like that, and I can give you comments line by line, things like that. So it makes communication a lot easier. Does that make sense? Isn't that cool? How do you get started? God, I'm an idiot. But yeah, you can also install Eclipse. Install IntelliJ. Better than Eclipse. I'll go change the link. Politicians promised. You need to download the JDK. I am assuming that you have a computer or 5. And I'm assuming that no matter what you do, it looks different than mine. So I'm not going to try to make the screenshots look like anything, right? I have Windows machine or 2, a Linux machine or 2, and a Mac. Chances are that I could try to help you with whatever you have. You may have some weirder stuff, but so download the JDK. Download any version of 8, Java 8. And you need to download the JDK, not the JRE. JDK stands for Java Development Kit. That's the first thing. That's the compiler and the JVM. So that allows you to compile programs from Java to the JVM and run programs that have been compiled. I expect you to get Git. Let me ask you, just to confirm, how many in here use a Windows box as your main machine? How many use a Mac? How many use Linux? How many don't have a main machine? Who didn't raise their hand? Do you not have a computer? Do you? Sorry?
Chromebook.
Oh, a Chromebook. Oh, God.
Yeah, now probably they need one.
Maybe. Termux, new Chromebooks now run Android apps. Termux is a Unixy thing. You can also do Crouton and stuff like that and get a real Linux. A Chromebook is Linux explicitly dump sized so that you cannot mess it up. But now you're gonna learn how to mess it up. That's kind of the easy thing to do. But Termux doesn't mess it up. It's an Android app that gives you a Linuxy stuff. Might work.
Okay.
If not, Crouton definitely does work and gives you kind of a full Linux on your Chromebook. Or pay $5 for a server on DigitalOcean or something like that and use that.
Okay.
Talk to me afterwards. I can actually give you, I have a server. I can give you an account there. Which may be more painful, but maybe.
Extra credit.
Yeah, maybe actually more painful then. But if you have Windows, this thing actually installed Git Bash. Windows, up until recently, had a horrible command interface, right? Because they had MS-DOS, and then they hated it, and they tried to build a GUI and tried to not make commands, so their command tools sucked horribly. Actually, PowerShell is nice, except that they have 7 different versions, and they don't all match, and that stuff. This thing gives you Bash, which is a fairly decent shell. A shell is just a program that takes your commands and does stuff, right, for you. And so bash is a fairly nice one. It's available on the Mac. It's available on Linux. And with this, it gets installed on your Windows box. So you open a command thing, and you can run commands. Makes Windows almost usable. So you would need that stuff, and it also includes Git, which is our version control system. And then Eclipse, or actually IntelliJ. And I am asking you to create an account on GitLab. Some of you already went to D2L, I don't know if from this class or from the online class, and have started sending me that email. That's going to be the first thing. I want everyone here to go do that today, tonight. Create an account on GitLab. And, oh man, people, ooh, some people are good. They already have pull requests. You guys are way behind. He still didn't make the August 13 deadline, but.
Was when I went and did that, like so I made my account, and did I mind just emailing you like my username?
Yes.
Okay.
Your username and your SPSU username. But I'll figure them out. Or actually, I've also created, I hope, a thingy here, a discussion group on D2L, so that you can also put it right. I mean, it's gonna be chaos for the next day or two, right? Because I'm gonna be receiving a bunch of emails, right? And so I try to make it every possible way so that no matter which way you send it to me, I still get it and I still give you the account, right? And so, but be prepared for chaos. It's normal. And that will allow you to do stuff. Now, let's talk a little bit. We'll probably go over assignment 0 on that stuff, although it is here next class. Let's cover a little bit of stuff so that it makes sense. And I'm gonna cheat a little and use Java REPL. For the most part, what we do in traditional programming, in imperative and object-oriented programming, one of the main things we have are variables. Variables are names for locations of memory, and we can stick values in them. They're like boxes, and we stick values, right? So a variable has a type. For computers, it is important to know what kind of stuff is in there, to know what kinds of things they can do with, right? So if we say it's an integer, then we know that we can add, subtract, multiply, divide. If we say it's a string, a bunch of characters, then we can probably add or concatenate two strings, but multiplying doesn't make much sense. And dividing definitely doesn't make sense, right? So we declare a variable by putting the data type, the variable name, and a semicolon. So what do they do here? Declare a variable named a of type integer, right, or int. I can also do this, and this, you remember algebra? Forget it. It has nothing to do with this. This is a lie. This is an abomination. No. In algebra, what does this mean? A equals 10. That means a equals 10 and will be 10 forever, right? In programming, what does a equals 10 mean? Stick 10 into the box named a, right? And then maybe later on I'll stick 11 in there, or 23. Does that make sense? So in programming, it is, right now it's 10. You have to look at the rest to see what will be. Variables actually change names, that's why they're variables. They can vary. Does that idea make sense? So this will make A be 10. We can also do stuff like this. A equals 3 plus 4. So what did we stick in A? What's the value of A? 7, right? We'll probably see, I tend to see this stuff in isolation, so we can go talk about all the things that you can put on the right-hand side of an equal sign, right? You can put methods and whatever, right? And it's like, well, expressions, and it doesn't matter, right? We can go talk about all of them, as long as you remember that you can then do A equals whatever, right? And so we'll talk about it that kind of way. So in Java, we can do stuff like this, which should horrify your algebra teacher, but it's normal for programmers. What do we do here? Declare a variable named of type. Cool. What does this line do? Int b, right? It's a variable of type int and it's called b. What does this do? Set a to 10. What does this do? A plus 1, which is what? 11, right? And then A equals B plus 9, so that will make 20, right? So we can go play with Java REPL. We can also do it like this in one line. So we declare and initialize. How much is B gonna be? How much would C be? Minus something, right? Negative 11, yeah. Can you see why? Can you actually see the screen? Is this? I don't think I can make it bigger. It will adjust itself. It doesn't increase size. Sorry? No, they are using beautiful HTML that ignores my things and will just, I think. Yeah. No. Haha. It can expand? Maybe. Yeah, and this stuff doesn't expand. So I just managed to mess it up. Isn't that cool? So we can declare and initialize. We could declare a bunch of variables in the same line. I tend to not do this a lot. Important stuff, variable names, right? We should use meaningful stuff. It is sometimes okay, and actually for most of the first couple of lectures, I'm gonna ignore my advice, right? I'm gonna name things like A and B because, well, we're just playing with stuff, right? But normally your variables should denote the meaning, right? It shouldn't be A and B. It should be age and something that starts with B. Number of bottles or something that would make sense to be. This is going to be super important when you go doing bigger and bigger programs, try to stick with it from the beginning. Because in the beginning, you can name your things A and B, and it'll probably work. You'll just get a bad habit, and then it will not work when you try to do bigger programs. Variables are composed of letters, numbers, or digits, the dollar sign, and the underscore. And they cannot start with a digit because Java would know where you meant an int or a variable. The dollar sign is actually a possible number, a possible thing, and nobody uses it, and everybody would be horrified if you use it. So don't. Underscores are possible. Java distinguishes between lowercase and uppercase letters. Variables with different casing are completely different variables. Capital A is completely different for lowercase a, which is sometimes used, sometimes abused. Try to be very precise with your upper and lowercase. There is no specific limit of how many letters you can put in a variable. There is eventually a limit, but you'll get tired before the compiler does. There is a very strong convention in Java. The compiler will not complain if you don't do it, right? To start variables with a lowercase letter and use what is called camel casing. So use capital letters to separate words. So you would use number of sides like this. Does that make sense? Other languages have different conventions. They may start with a capital or not. And many other languages use underscores to separate words instead of use the capitalization. Unless you have a terrible preference for something else, use this, get used to it. It'll make your life easier because that's what everybody else is doing. The really important thing is be consistent. Unless your brain has been warped by something else, just go do this one for the next 6 months. What are the integer operators that we have? We have the standard mathematical ones with slight variations. We have plus and minus, and actually unary plus and minus. They behave normal. The operations are evaluated from left to right in the order in which we read them. So 3 plus 4 minus 1 minus 2 would be 7 minus 1, 6 minus 2, 4. Which I think is what normal math in elementary school does. But it's been a long while since I've been in elementary school. The multiplication operator, sorry, my markdown killed me. The multiplication operator is actually the asterisk. That's times because the X letter is a letter, right? One important thing is that the slash for ints does integer division. So you need to go back to elementary school. What is 5 divided by 2? 2 with a remainder of 1. It's not 2.5, it is 2. The slash for ints will do 2, and the percent will do the remainder. So 5% 2 is 1. The remainder of 5 divided by 2. Does that make sense? We can mix and match this with the usual orders, PEMDAS, but there is no operator for exponents, and use parentheses to modify the order of operations. As usual, if in doubt, use parentheses. If you get confused about what's the order, especially when we start doing some of the other stuff, use parentheses. Makes your statement clear, will not confuse the poor guy who's going to be reading your code at 3 a.m. in the morning. That poor guy may be me, that poor guy may be you when you're trying to debug, right? So you definitely want to make that poor guy's job easy, right? Um, just to add more confusion, and we're going to stop here, Java supports shorthand operators. We tend to do stuff like this, a equals a plus 5, right? And we tend to do this stuff so often that Java stole a lot of stuff from C. C became super popular, and that basically every language looks like C. So they all do this stuff. A plus equals 5 is just shorthand for a equals a plus 5. Does that make sense? And we can do that with all of the other operators. B times equals 3 is b equals b times 3. And then we have plus plus and minus minus for plus 1 and minus 1. Next class, we'll start from here and we'll talk about floating point numbers. Let me just put one more idea in your brain before you leave, and that's the idea that integers in computers are not quite the same as integers in math. Eventually, you run out of digits. Eventually, you run out of bits, right? I think in Java, ints are 32 bits, which leaves you from minus 2 to the 32 to 2 to 32-ish. Yeah. One of them, I think, is 2 to the 32, to 31 minus 1. So it's from like minus 2 billion, 2.5 billion to 2.5 billion or so. If you want bigger stuff, you'd use longs, which have 64 bits. And so they're from like 4 or 5 trillion to minus 4 or 5 trillion or something like that. The important thing is not the specific things, although you will memorize them probably, but the fact that eventually you may get out of the range. And so 2 billion times 2 billion is not 4 billion, it's minus 7. What? That's because you got out of the range and you wrapped around. Cool. I will see you guys on Wednesday.